Hello, everyone. So we're going to be talking about the metric store here at Databricks. And before we get into that, there's some legalese here. The legal team does not trust me. They don't want you to believe anything I say, but you make your own judgment. Before we get too deep into it, let's first take a trip back in time. The year is 2016, and I found myself reading a really spectacular email. Not a good one, but a spectacular one. It was an email that set the trajectory for the next 9 years of my career. It was our CEO asking for a simple metric. How many visitors do we get? Pretty basic, you'd imagine. But it kicked off a flurry of responses. You wouldn't really expect that. You'd expect one response, but it started with one number, then there was a second, then a third, and people had to start triaging. That's the wrong table. Uh-oh. That's the wrong filter. No. That's not visitors, that's users. Right. So more and more people were pulled in. Analysts, data scientists, product managers. Dashboards were linked, queries were pasted. It was a mess. Let me pause here for a second. Have any of you experienced something like this? Yeah? We're all in kind of the same boat. Inconsistent sources, conflicting metrics, stale definitions. These are easy mistakes to make, especially at a growing company. And that's actually the origin story for the first metric store I created. It spurred a 5-year journey building Minerva with Cristian here and many others at Airbnb. And after a short 5 years, it was a source of truth for business metrics at Airbnb. It housed thousands of metrics. It had 20,000 global dimensions that could be attached to those metrics. It was capable of serving hundreds of thousands slice and dice metrics at sub-second latency. And it was a source for forecasting, anomaly detection, experimentation. It was used by every single org and team in the company. The source of over 60% of executed queries. But as you can see on this slide, we're no longer at Airbnb. We're instead, for the past 4 years, we've been here at Databricks building another metric store. So let's step back a little bit and talk a little bit about Databricks. At Databricks, we believe data and AI should be infused into every function of your business. So we strive to do that ourselves. To support this, our team, the internal data platform team, maintains the single largest and most complex Databricks implementation in the world. Nearly 100 workspaces, over 10,000 users, spanning every single supported cloud and using nearly every feature available, including some you haven't heard about yet or were just announced this week. We do it all. Like you, we are customers of Databricks, using the same tools you know and love, almost exclusively. We do this so we can get the most out of our data, so that our decisions can be data informed, so that we can automate actions, so that we can keep making the product better and better. We want to infuse data into everything we do. But how can you do that if you can't agree on what's true, on how many visitors you have? How many of you flag data incidents and run postmortems? Anyone? Yeah, a little bit? Let's go over that email a little bit. Take a second and go over that email. That's the wrong table. How many of you have multiple tables that can answer the same question? Yeah, more of you. All right. It's a very common issue. Multiple tables reporting similar or the same data, and they go out of sync. It's not really the wrong table sometimes. It's just a different table. And your operational and development processes are struggling to keep things aligned. Now, you're never going to really get rid of this duplication. It's a necessity in many cases. It exists for good reason. Whether it's for performance or freshness or something else, it exists for good reason. But this highlighted that we needed a solution that could guarantee consistency across tables. If a fix needed to be made, it should be easy and comprehensive. No, that's the wrong filter. This is an important metric, so many teams track it. How do they do that? They copy and paste the definition into their dashboards and tools. But the recent PSA signed off by all the execs said, we should only count a visitor if they stick around for more than 30 seconds. There's dozens of copies of this old definition. Guess who didn't update their dashboard? Everyone, right? No one updated that, right? We need a way to centralize definitions, avoid duplication. If logic needs to update, it should be easy and comprehensive. No, that's the number of users. Vocabulary is localized. Even within a single language, there's multiple dialects per region. Right? Raise your hand if you say soda. Right? Anyone say pop? I was born in Texas, so I say Coke. Right? Everything's just Coke. Businesses are the same. What one team calls visitors may be what another team calls users or customers. Right? Within your company, people use the same word to mean different things or use different words to mean the same thing. So if the question is posed to the entire company, you're going to get different answers. People are going to be confused. So this really highlighted that we needed consistent terminology. We all needed to talk the same dialect. And it came down to having a poor foundation. It was the Wild West in our lakehouse. Every team had a different way of implementing pipelines and defining metrics. Different tools, different languages, different change management, different observability and source control. Again, it was a mess. We were collaborative, but not really. Teams communicated and worked together, but the lakehouse was just a bunch of black boxes connected to each other. No one really knew what anyone else was really doing, what the logic was in those other tables or pipelines. And over time, as the product grew, the company grew, the orgs grew, the teams grew, and this problem grew. We had no platform that everyone could come together and contribute to. If someone saw something they needed, they just made a copy. So the metric store was made not just to be a store of metrics, it was also an ETL tool. It was intended to provide that missing foundation. Add some reinforcement, some wood, some rocks, give teams structure, standardize how data is defined, created, managed, build some guardrails, add some rigor, and obviously automate as much as possible. We built a place where the entire company could come together, contribute their knowledge, and be a repository of all business semantics. Let me repeat this with a little bit of different imagery. We had this state where metrics were duplicated across all of our different tools. We wanted to move away from this, because how can you possibly keep metrics that are duplicated across all these in sync? And don't get me started on LLMs as well, right? Like, how can an LLM tell me how many visitors we have if we have 20 different, fairly valid answers? So we wanted to move away from this, and we wanted to move towards this. We wanted to centralize our definitions, have one definition, one place, with one meaning, one semantics, one name. This would be the source of truth, the source of truth. But we weren't really sure how to build that. We know what the problem is, but we're stuck on this core issue. What does it mean to centralize your metrics? How do you define metrics in a way that everyone can use them? How many of you have seen people document metrics as SQL queries in spreadsheets. Yeah. We started with that. But does that solve the problem? They're going to copy that definition into Tableau, and then what's going to happen? Right? Are we going to be able to notify them when a change needs to happen? Are they going to remember all the places it was copied? No, those copies are going to go stale. Maybe not today, maybe not tomorrow, but at some point you're going to get that email again. And this is the reality at a surprising number of companies. Well, maybe not surprising given the hands that are up. Some companies don't even bother with spreadsheets. They'll use a Google Doc or Confluence or Slack channels. And some don't even bother with that. Some of them just say, hey, if you want a metric, go ask someone. Some poor data analyst is expected to know everything about the business and be on call 24/7 to answer questions from everyone in your company. And I hope that's not anyone in this room. If it is, I know it's not your fault, I'm sorry. We really needed to solve this source of truth issue. If someone needs a metric, they need to come to the metric store. And the definition needs to stay in the metric store. And I mean all the definition. If you're generating a cube and calling that your metric store, and people are still adding some aggregation in their query as they query that cube, you're still going to run into the same problem. You're going to get one of those emails. Someone's going to do the wrong aggregation. So again, how do you define metrics in a way everyone can use them? If you attended my other talk, you know I love this movie. We were limited by the tools available to us. We can define a metric in BI tools. Tableau knows what a metric is. Power BI knows what a metric is. But the lakehouse, like we have tables, we have views, UDFs, volumes. I mean, now we have apps and models and LLMs, but what's a metric? It doesn't know what a metric is. Approaching this problem it's like starting your trek, and you're staring up at that first mountain, and it's huge, it's intimidating. How do I tackle this? Again, how do you define metrics in a way everyone can use them? I keep repeating myself. I promise I'll get around to it. I'll tell you the answer. We had already tried spreadsheets. We could store it in tables, maybe create cubes, but again, as I said, that's not really going to solve the problem. We could try fully computing these metrics, store it all in a table, treat it like a KV store. They would just do lookups. They don't need to do any aggregation. It's just a select statement, right? But then that's a lot of permutations to cover. That's a lot of compute, a lot of storage. Your cloud vendor is going to love you, but your data infra team is going to be really angry. So we're back to square one. That's 3 different designs, all still failing us to get past that first mountain. So we hit the whiteboard again. A little defeated, but still determined. We needed something brand new, some outside-the-box thinking. Something our lakehouse currently wasn't capable of. We needed something like an API. And this is actually something a lot of other metric stores have tried to do or really had to do because it makes sense. When you build an app, do you give users direct access to your backend database? No, you build an API. It provides a ton of flexibility and abstracts users away from the technical implementation. You can surface specific knobs and controls, and users can self-serve. Meanwhile, it buys your data engineers a ton of freedom to perform migrations and evolve underlying data sets when necessary. That's a win-win, and it sounds great. So we did it. Hooray, it looked a little bit like this. It was primarily a JDBC connector backed by a metric store service, which had all the definitions. Users first had to decide that they wanted to query the metric store. Then they had to change their connection and query the metric store. But when they did, magic. This magic decomposes the user's query, tries to understand what they were asking for, and then writes a new one based off the definitions that were in the metric store. Then it executes it against the lakehouse and returns the results. This wasn't the wrong solution. Again, we did it, it worked, and as I described, it was successful, but it was a very painful solution. It's querying the metrics for you. So say goodbye to access controls unless you want to implement that in this layer. Right? And it's a lot of complex logic. There's a lot of blocks and arrows here, a lot of stuff to build and maintain. This is an effort that spanned more than 4 teams and several different job titles. Have you ever written a SQL parser? The magic I mentioned before is great, but only until it doesn't work. Your users are not going to like those confusing error messages. So I say all this to say it worked, it was successful, but don't do this, right? I'm showing this to you, but don't do it. Don't live in the past. If you've been paying attention to Unity Catalog presentations, if you watched the keynote earlier, or if you were at the UC presentation about an hour ago, you may have noticed something called metric views. In fact, we've been giving these sneak peeks, and some of you might already be users of this. It's been in private preview. I think it just went into public preview. Metric views is solving this API problem for us by making metrics a native concept within Databricks. That means you can now define a metric in this YAML. This is a very simple definition, but there's metrics there. You can then see it in Unity Catalog. So instead of seeing a table in UC, you would see this, along with logic on how is it going to be aggregated. How are you grouping those dimensions? And you can query it by SQL, by name. You can query these metrics by name. This isn't some KV store lookup or a SQL query in a spreadsheet. It's an actual metric in your lakehouse. And that's a pretty basic select statement. There's not much there. So we can define how measures should be aggregated, store and publish that definition, and do it in a composable way so it can be reused over and over and over again without copy and paste. And let me repeat that. They're composable. So they can be built on top of each other, and you can choose to inherit definitions. So if the data engineering team's too busy and they can't help you, you can unblock yourself safely and easily. You can evolve those definitions safely and easily as they need to change. And since it's native in the platform, it plays nicely with other tools like Genie Spaces. Point the Genie at some metric views, and the LLM can easily retrieve metrics. Perfect accuracy. No complicated generated SQL, no hallucinations. It's all been vetted by your analysts or data engineers or analytical engineers, whatever your title is. And in Lakeview, a non-technical user can now select some metric views and create a dashboard without having to write a single line of SQL or even defining any logic at all. They just have predetermined logic available to them that they can then now slice and dice by. Business users are able to self-serve. It's like having an escalator carry you to the top of that first mountain. But when you get to the top of that mountain, what else do you see? You see more mountains. There's still more to do. Because building a metric store is actually a journey. We solved the biggest hurdle. Now we have a way to build and consume metrics. But how do we maintain them? A lot of that is going to be something Databricks can't do for you. It comes down to what you want to do as a company, how you manage data in your company. And a warning for any execs in this room, this is not something you build as a one-off. It is something you need to continually invest in and evolve. Now, I'd like to invite Cristian up here. He'll tell you a little bit more about this journey, about these other mountains and what you can expect from them, how we chose to conquer them twice, and why this is all completely worth it, why it's worth that investment.
Thank you. Hello, everyone. Welcome to your last talk of Data and AI Summit. I'm Cristian. I'm going to teach you how to build a metric store. By now, we're very clear on what is a metric. You may be familiar with UC metrics. And are we done here? Can we go home and celebrate? Of course not, else I wouldn't be here, right? But before I tell you the feature map, the 12 main qualities that any successful metric store should have. Allow me to tell you on how we got to that map. What is the principles that we use when building a metric store? The first principle should be clear from what Amit just said. We need guaranteed consistency of definitions. One name, one metric, one semantic, independent of where it's stored. This is the essential property of a metric store. But consider this, is a single definition consistent? Well, yeah. Is it useful? Absolutely not. You need an ecosystem of metrics and dimensions. It needs to be accessible to the whole company in order to define and consume, which means onboarding and developing shouldn't be prohibitively complicated. And how can we make this happen? What is the second principle? Let the users focus on the business logic. High accessibility lets users that work very close to the product to be contributors. Think PMs, analysts, data scientists. They understand the metrics best. Let them contribute directly to the metric store and don't play the game of telephone when one tells the data engineer and the data engineer goes back to the product and then the product goes back to the data engineer and then you get the definition. You want to reduce this to one step. That means accessibility. Now this is great. People can contribute. You can build consistency. You make sure that these data sets, the semantics, are all over consistent with backfills. But imagine this. We have Johnny. He's excited to add his new metric definition to the core business data set that's used for analysis. There are some redefinitions there, but it should be a quick backfill. Not a big deal, a couple of days. The following day, unknowingly, Stephanie is modifying the geolocation definition to be based on IP rather than registration country. Another innocent change. 2 days later, separately, Peter noticed there was a data issue in a specific month and has been corrected, so he wants to trigger a backfill. Now, what do these instances have in common? Well, these are people that love blue sweaters and glasses. But these are also people that were just working independently, modifying a core data set that kept triggering backfills. And popular data sets can have a great range of changes that modify them. They're popular for a reason. They aggregate the data from all over your org. They have multiple metrics and dimensions. Unfortunately, these popular data sets are used in very high-stakes situations. Think business reviews, customer insights. So when they become unavailable, the company stands still, which led to the third guiding principle that usually comes after a big incident. If the data is not showing, we are in trouble. Consistency and availability. They're always going to be at odds with each other. You want to make sure that all your data sets are consistent, but that requires backfills. Backfills make the data unavailable. So how can we deal with this? Well, we need operational tooling. With operational tooling, we can have our cake and eat it too. I'm talking about parallel backfill environments, incident response protocols, partial backfill tooling, etc. So when we put the three principles together in action, we're talking about consistency, quality, and availability. Consistency, I touch a little bit. It looks a little bit like this. You have your warehouse, you have your engine, you have your storage, you materialize the data, then you have your views that control when you publish that data. Then you have DLT or jobs for orchestrating these semantics. And on top of that, you have the consumption layer for the users, the part that people love. UC metrics, Genie rooms. How do we get high quality inputs? Well, you don't want people to be familiar with the engine that's computing your semantics and making the consistency. You want them to just focus on their business logic. So you build configs, a thin config layer. Then you run validations in GitHub, compiling in a Terraform, everything's running from the same Git shop, and you have your consistent environment. That's good. I'll go into detail later, but the last thing that you need in order to get availability, operational tooling. You need to have some mechanisms. If you have one data scientist that's going to be like maintaining several data sets that are going to be served throughout the whole company, you need operational tooling such that this person can self-serve. And when you the reason why I show all of this together is because when you look at it as that, a configuration layer that powers an engine, that has operational tools that you can run on top of it, and squint a little, you realize what this is. This is a control plane for data. Yes, we built a metric store on top of it, but we built it designing a control plane for data sets. And when you build this, what you have is accelerated development, which means one data scientist can maintain 40, 60 data sets, no problem. You have improved data reliability and standardized, freshness SLA, data quality checks. What are you going to run? All of those are standardized in the library. And you have reduced operational overhead. People are focusing on the business logic, not which Hive version you're using, not which Python version you're using, etc. And the best, and this is the means to the end, guaranteed consistency and available metrics. I'm going to divide this in 3 parts that I'm going to tell you the 12 main features, 4 per part. One is the consumption layer, the semantic layer, using metrics, Genie rooms, but there's a little more in there. The other part is the operational tooling. What are the tricks that we did in order to make sure that this is available and consistency doesn't become a hurdle? And last is the foundation. If you are starting from scratch, if you're just getting started, get this part right. Because when you get this part right, you can't just build a metric store, you can build much more than that. But before I go into the technical jargon, I want to go with the value. In the past year, there have been 2 cases that I want to highlight here that were built in this metric store. And this is what you can expect when you have it in production. You are the CEO of Databricks. Which is the dashboard that you want to see every morning? Well, you can imagine it, right? Growth, churn, which products are which person using, etc. You want to know how much your favorite AI company is spending on Databricks? Nah, not going to show that. But I'm going to tell you about product feature tables. So every feature that we have in Databricks, we have usage log for it. DLT, notebook, serverless, etc. We grab all of these logs, completely anonymized with random user IDs and whatnot, redacted to protect the privacy of our customers, but just enough that we can do analytics on it. Then we go through a process of reconciliation to make sure that our metrics don't jump every 3 months when we change the user IDs. And then we build very wide tables at the user, workspace, account, and customer level that tell us how everybody's doing on each of these features like notebook, DLT, Lakehouse, Unity Catalog, UC metrics, etc. This is what powers that customer insights dashboard. And it was built by one data scientist. It contains 30 data sets, right now closer to 50, which are fact tables that contains the usage logs, then pseudo user, etc. And then eventually builds the features, which is a metric on top of a time window. It contains 18,000 features that help power the decisions of Databricks to make sure that we're doing the right thing for our customers. It seems made up, but it was really a platform within a platform. PMs contribute to the configs of product feature tables, which trigger datasets definitions inside of the metric store, which power the product feature tables dashboard. Second example, QPL. And before I go into the detail of what QPL means, a quick play of words. When I say Databricks, you think, what is your favorite Databricks product that you associate with Databricks? Is it DLT, notebook? Raise your hand if it's Spark. Well, those are my old-timers here. Query performance logs. The story of Spark and Databricks is basically similar to UC metrics and metric store. It's the building block that started this company. The Databricks internally provides a runtime called DBR. It's Databricks runtime. It's a version of Spark that's supposed to be the best for our customers when they run in our warehouse. This is the one thing Databricks cannot get wrong because it powers so many things. There's no moment more intense than when we're launching a new DBR. Because when we have a new version and then we detect regressions, we can celebrate, yes, we got 12 regressions. But then somebody says 2 weeks too late. And it's like, well, sorry. So we built a framework where we can, just like before, usage logs, cluster insights, properties from the cluster, and try to determine if there were regressions in the new version of the release. This is, again, one data scientist. It generates 60 or more data sets at this point. And it has prevented 20 regressions from actually touching our customers, protecting our customers, and delivering on the promise. This was the story of 2 data scientists. What would you do when you have 40 data scientists? Now, this bingo card is the last part of the talk. And I'm going to go on to what are the 12 essential features, touching 4 features in each of the main layers of the metric store: semantics, core, and foundation. Semantics is the consumption. And it's the first part I'm going to talk about because, let's be real, the core and the foundation are not touched by the consumers. The consumers touch the semantics. A metric store is a 2-sided marketplace when we have data producers and we have data consumers. Data consumers only deal with the semantic layer. So that's the part where I'm going to start with. What do you need in that top shelf? Well, it needs to be a single source of truth. How do you achieve a single source of truth? Validations, 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 lots of CI and CD. One good thing to add on top of the single source of truth is data certification, because not all your data sets are at the same stage. So you want to have these special data sets that you know, hey, these guys get reviewed every 2 years, and this is the top quality data. Second, denormalization. Your data is going to follow your org. This means you have to find a way of putting all of that together in order to get these wide views. Hence, your metric store needs to be a denormalization framework. Third, anomaly detection and forecasting. If you try to build anomaly detection and forecasting and empower it in your org, you probably run into the main doom that has this thing, which is noise. People quickly turn off the anomaly detection. What's the cure to noise? High quality data. Hence, we put it in the semantic layer instead of the core or foundation, because we want these models to be powered by high quality data. And last, this is the first gray box. So let me explain what a gray box is. A gray box is something that you have straight out of the box when you use Databricks. You can see foundation is mostly straight out of the box. And here we have the main thing that we use from Databricks straight directly, which is metric views and Genie rooms. In terms of reports, it needs to be in your semantic layer. You want standardization, because what does a quarter mean? Is it from January to March? Well, not if you work in Databricks. Is month over month 30 days? Is it 28 days? You want a standardization. Standardization leads to greater cross-org collaboration. So your metric store needs to have some sort of semantics in there. And ML, well, in order to have fast iteration of models, you want to have high quality data feeding your training data. So your metric store should be able to power those training data sets. This top shelf sells, and it sells pretty hard. But it's a very useful consumption abstraction layer that can actually help you migrate all of your data sets from lower quality to higher quality, and without anybody having to change their consumption patterns. Now, I'm going to move to the middle shelf, the operational one. If somebody's giving you a metric store and they don't talk about the middle layer, well, likely it's not going to scale. You want to have versioning on your data sets. You want to have self-healing. By versioning, I mean grab the semantics that require a recomputation of your data set and materialize the data based on that. This is very helpful when you want to have data rollbacks, because then you can go back to the previous version. And for self-healing, I mean, the best data incidents are the ones where you don't have to do anything. So if data arrives late or whatnot, make sure that your data sets actually fix themselves based on the state of the storage. This is what allows one data scientist to maintain 40 plus data sets. Alerting. This is a kind of a no-brainer, but there's a nuisance here. If you maintain a platform, you know it. If you maintain a server, you know it. The 400 errors and the 500 errors. 400, you messed up. 500, we messed up. So you want to have alert routing, you want to have freshness SLA, you want to have all of these good quality of lives. Now, this is I would say the most important part of the core, and it's the offline backfills. This is what made our dataset successful, our metric store successful, because it balances availability with consistency. And by offline backfills, I mean you want to update your dataset. You grab your changes. You have a whole production consistent environment. Then you grab the changes that you want to put in your next consistent environment. You lock them down, and then you backfill it. And then you switch the version from the previous consistent environment to the new consistent environment. And you have immediate availability because they were backfilling in before. This is a pattern that we took from servers where they have a current and a next, and now we just apply it to consistent environments. And last, infra upgrades. This is not minor, but I mean, have you ever done like Hive 0.10 to Hive 2 migrations? Or, I don't know, Spark 2.3 to Spark 3.11 migrations? It's always something. There's always some function that changed the signature. Well, because we have offline backfills, because we have versioning, because we have separation of business logic and infra, we can actually test all of these migrations before they hit production. No more save once, no more incidents. You just test your migration, and then you just like merge it. Last, the foundation. The middle was very interesting. But there are some successes of the metric store that are unrelated to the metric store. And some of that is based on a good foundation. You know what our third-party ingestion framework runs on? Well, the metric store foundation. Do you know what our SOX compare data tool that we have in order to move data from SOX workspace and make it queryable in our central workspace? The metric store foundation. So this is the part that I feel it's worth to get right. And the good thing is that everything's a dark gray box. So you can use Databricks right out of the box and build a good foundation. What does it consist on? Validations. Get your code version, have CI/CD practices, and validate. The best bugs are the ones that never hit production, right? So one special validation that I want to mention is, have we updated the docs yet? Why? Because we live in an LLM world where IDEs have access to an agent that versions in your repo. So your first line of customer support can become an LLM if you have good documentation. So just build CI on it. Second, orchestration. You have to have a way of orchestrating pipelines. If you were today in the keynote, then you're going to think, well, Spark declarative framework. We can use DLT, we can use the jobs API. You have to figure out your orchestration and commit to it. Third, you have to have a way of switch testing, not in production. I know it's basic, but if you use unit catalog, then you can just have the same data imported from production into your test catalog, run it, and compare data before you even have to do anything. And last, governance. You want to make sure that your metric store has all of the data. You don't want everybody to be able to access this data. This means that you need to have restrictions. With one line of changes in the config, you can restrict that data set in the metric store. So when you're cooking, you want good ingredients. These are the good ingredients you want when you're building a metric store. So I'm basically out of time. So let me just remind you what we built here. It's thin layer of config that lives in GitHub, deploys through Terraform, all with the same commit, built on your data lake, views to control the exposure of data, and Genie rooms and UC metrics. I can promise you the results of building a metric store because we did it. I gave you the examples, the values that we have. And depending on where you are on your journey, you may want to focus on either the foundation, the consumption layer or the operational tooling. May your metrics be consistent, available, and high quality.